Okay, and we are live. Hi, everyone. Welcome again to this book reading club session. It's going to be the second session for the book that we're reviewing at this time, which is Hibernate Tips from Thorben. Here we have Thorben. Oh, Thorben actually has the hard copy to show up. So now, can you show it again? Yeah, awesome. And here with us, of course, we have Ivan, which is a colleague of mine, the help of running the book reading club. Say hi, everyone.
Hi, everyone.
And of course, we have Thorben here that's going to be our guest speaker for today and his book, Hibernate Tips. So before we dive into the book, can you please introduce yourself, Thorben?
Yeah, sure. Hi, and thanks for having me. My name is Thorben Janssen. Some of you might know me from my blog, thoughtsonjava.org. And, well, I wrote the book we are talking about today, Hibernate Tips, More Than 70 Solutions to Common Hibernate Problems. And, yeah, I think they're the most important parts about me for this column. Basically a trainer and author and consultant in the Hibernate and JPA space, working with these kind of topics for about 15 years now. So started with one of the first Hibernate versions. And yeah, I'm happy to talk with you about my new book.
Okay, awesome. So for people that didn't attend the other sessions, so what was the reason why you thought about writing the book? What drive you to come up with something like that?
Yeah. So first of all, it's basically a cookbook with a bunch of recipes for common Hibernate tasks or issues. And the idea started more than a year ago with a few blog posts. So I got questions on my blog, and I recognized that a few of them repeated, right? Basically, quite a lot of them were repeated questions. And I started to write the Hibernate Tip Series, in which I took a question and provided a direct answer to it. So not a lot of explanations, just a short introduction to the topic, a code snippet, and a quick description of the theory behind it. And I got quite a lot of good feedback for that theories, and I continued it for several months. And at some point I thought, well, if this is a good format for a blog post series, why not create a book out of it? And I did that, took a bunch of Hibernate tips from my blog, wrote more than 30 additional tips new for the book, and published these at the beginning of April.
Awesome. Okay, so today we're going to look into the second half of the book. So we came up with some of the most basic stuff in the first session, and now we're going to hopefully go into more advanced stuff. So for the viewers that are watching us at the moment, you're able to join our IRC channel on VirtualJug channel. So you can go there by our website, virtualjug.com. So you can post your questions on IRC, and I'll be happy to relay them back to Thorben about the Hibernate Tips book. We're also doing something additional, which is the YouTube link also allows you to post live questions directly on the live chat over there. So it's something new that we're trying out. So feel free to post any question on the YouTube channel as well. And I'll be happy to relay any of those to Thorben. So to kick our session, let's start with some of Ivan's questions that he prepared before.
Okay, so let's warm you up a little bit. First of all, the topics for today, to remind you, the topics for today are logging, JPQL, native SQL queries, stored procedures, and caching. My first question is I prepared is on logging. So in most of the tips in the logging chapter, you, Thorben, state that you don't turn that feature on in production because, yeah, it may use some useful resources. But are there any useful logging or auditing features that you would recommend that are always turned on in production?
Well, in production, you normally just want to get the best performance out of your application that you can get. So if you're not having any issues at the moment, or if you haven't updated the system recently, then I would just activate the error logging and don't activate the Hibernate statistics, don't activate any debug logging. Just reduce the amount of log messages to a bare minimum, which are basically error messages which you need to see if something bad is going on your system. But besides that, I would reduce the Hibernate logging to a bare minimum. If you need a few log messages to understand what's going on your production system, then you should handle this in your application layer, because there you know which use cases are executed right now, and you have a lot more options there to really write log messages that are on a higher level and really allow you to understand what's going on in the system. But Hibernate just provides a basic service in this case, which database communication. So it's nothing high level. And then you shouldn't activate any logging there on a production system. Given that it's a stable application, you didn't perform any update recently and all these kind of things. If you have any issues, then of course you should think about increasing the log level, and maybe even activate the Hibernate statistics to get internal information about the system. But then you need to be aware that this slows down the application. Collecting information and writing log messages is something that you don't get for free. And as always, you have to decide which trade-off you want to take, either a slower application or more information about the low-level stuff that's going on your system.
Okay.
Hey, and what kind of actual, so you talk about some of things like Hibernate logs. Can you be a little more specific on what kinds of information that we are able to get when we get that logging or the statistics?
Yeah, I think the best thing is to share my screen for a moment. So Hibernate can provide you a lot of internal information. Let me have a look for this test case, for example. So you can, of course, statements. That is something that's a good idea to do during development, and maybe even while you're testing your application. So then you get something like this here, where you see the SQL statement that was performed by Hibernate.
Mm-hmm.
So there you see what Hibernate creates for your API calls and for the JPQL queries. That's something that probably most of the viewers here know how to do that. But I want to make sure that you don't activate it in the persistence XML file. That is what you here you should persistence XML file for this project. You could use the hibernate.showSQL parameter, which is not in here, to activate the SQL statement logging. But that has a few downsides, like Hibernate is logging to system out. You can deactivate it without changing your persistence XML file, which is in most cases within your deployment unit. So you need to change the binary that you deploy to your system, which are all things you should probably avoid. And you can achieve the same log output with your logging configuration. In this case, with log4j, by just setting org.hibernate.sql to debug. And if you set the org hibernate type descriptor SQL to trace, you also see the values for the bind parameters, which you can see here. So this is an input parameter, in this case, the author ID, and the following 4 lines here are the bind parameters that we got from the database. So it's the ID, the first name, the last name, and the version. So it's also an interesting thing you can get during development are the statistics we talked about. That is this block down here. And here you can see what Hibernate did during this session. So it acquired 1 JDBC connection and prepared a statement, executed a statement, executed 0 JDBC batches. We had no cache interactions, in this case, the second level cache. Hibernate performed 1 flush, which means it wrote 1 set of changes to the database and 1 partial flush. So what do you need to do to activate this? This is pretty simple. You just go to the either the persistence XML file, like in this example, and set the hibernate.generate statistics parameter to true. If you don't want to do that here, you can also set a system property, for example, and then Hibernate will pick it up from there and also write the log messages. When you activate the Hibernate statistics, then you should also activate the, no, that's the wrong file. Then you should also set the log level for org Hibernate stat to debug to see the execution time for each query. So we can have a look at this test case. Okay, so this looks pretty similar to the previous one, but now you can see here that Hibernate logged the HQA query that we executed in the test case. And it also tells us how long it took to execute this query and how many rows it returned. So if you use this together with the Hibernate statistics and probably also with the SQA statement logging and bind parameter logging, you get all the information you need to really understand what's going on on your system when you execute the test case.
Mm-hmm. So I'm guessing that most of the times that you will use something like this is for when you want to debug performance issues, for instance.
Yeah, you can use that to debug an existing issue, and this is one of the rare cases where you could think about activating this even on a production system if you're really desperate about finding this issue. But what I recommend in general is to activate these settings in your development system. So when you're implementing a new use case or changing an existing one, and set these parameters to or activate this log output, then you can analyze what Hibernate is doing while you implement your use case. So you really understand what's going on, and you can find performance problems before they occur in production, which is obviously the best case. Because there you can see, okay, on my test database, this query takes longer than I expected. Or you recognize that Hibernate executes maybe 12 queries instead of the 3 you expected, which indicates that there might be an n+1 select issue. Executing 12 instead of 3 queries doesn't sound like a huge issue, and in most cases is not a big deal, which is the reason why you don't find this without these log information on your test database. But when you deploy this to production and use a different database with millions of database records, then you might run into an n+1 select issue that really executes a lot of queries and takes really long to return to the user.
I see. Yeah, well, I mean, I think that's good information. So people know that they can use these tools to understand these kind of problems. Anyway, let's carry on. So we have no questions from the audience at the moment. But again, please, guys, use our C channel or just post any question that you might have on our YouTube live chat, and we'll be happy to relay it back to Thorben. So Ivan, can you proceed with your next question, please?
Okay, let's do it again from our site. So let's move to the next chapter, which is JPQL. That stands for JPA Query Language. And you briefly mentioned one of the new JPQL features coming with JPA 2.1, which is the treat operator. Can you explain its usage in a bit more detail? It's used in inheritance, I see, but how does it complement the basic inheritance features of JPA, like modeling the inheritance on entity level? How does it? What does it bring more than that?
Yeah. One of the nice things of inheritance with JPA and Hibernate is that you can create polymorphic queries. So you can, well, in the book, I use an example where we have a publication, which is this superclass of a book and a blog post. You can basically create a query that selects all publications, which means all kinds of applications, including books and blog posts that match certain criteria. But that's not what you want to do in all situations. And you sometimes know that you want to select a book and not a blog post. So what do you do if you just have an association between the author and the publication as the superclass, which would be the normal approach to model that? Let me just show that in the code. So sure. Here we have the publication, which is the superclass, the book, which extends the publication, and the blog post. And here we have the query example that we can use for this. So the author entity, which you can see here, has a mapped association to the publication. So this includes all books and blog posts written by a specific author. So when you now want to select all books written by an author that have a title which includes the word, contains the word Java, then you can use the treat operator, like you can see here, to downcast the publication to a specific to a book. So this excludes all blog posts entities that are associated to the author and contain the word Java in the title, which is something that the association between author and publication doesn't show. So we now run this test case. Here it is. You can see here the whole query that Hibernate created, which is quite a huge one. So we select the author and the publication, where the publication is a book with the word Java in the title. So Hibernate joins the author with the association table, because we have a many-to-many association here, and then joins that with the publication table and makes sure that the publication is of type book. And then it of course checks that Java is part of the book title.
So in this way, I don't have to have in my author entity. I don't have to have two separate fields, one for publication, one for blog posts, and one for books. I can do with just one field, and this treat operator will make sure that when I request the books, it will return just the books and not the blog posts.
Yes. So it downcasts the application to a book.
But what I'm seeing over there is that on the mapping, you end up having a type which will define what will be the subclass that Hibernate will use, right? That's why it adds that type on the inner join. So what will be
the treat operator tells Hibernate which subtype it has to use. So,
but I'm saying that gets translated into actual column which has a type, which has the So the question I was trying to ask you is, so what will be the difference instead of using that particular operator to actually just include something like a where clause, where I just set the type that I want, or something like that?
Yeah, well, the reason why you saw where we are talking about this part here,
exactly.
dtype equals book. This is there because I use the single table inheritance type to model the as an inheritance strategy to model the publication, book, and blog post hierarchy. And in this case, Hibernate maps all three entities to the same database table. So this table contains all columns for all entity attributes of the publication, the book, and the blog post. So Hibernate needs a discriminator column to differentiate if this record belongs to a book or a blog post. And this is something you can't access in your normal query. And it's an implementation detail for the inheritance hierarchy, which is something that you not necessarily know when you implement your query. So the treat operator allows you to encapsulate that. And you could even refactor your inheritance mapping and use a different strategy. And the treat operator would then create a different query.
I see.
So you're basically working on different detail levels here. So here you just work on the level of your entities. And if you would try to use the dtype column to determine the publication type that you want to select, then you would need to use an implementation and mapping detail.
Mm-hmm. No, I understand. I think that makes it perfectly clear. Okay, Ron, can you proceed with your next question, please?
Sure. Okay, still on the JPQL topic, and another very common use case especially for web developers, is pagination. So when I'm doing a web application that will get a huge result list of entities from the database, usually I don't want to drag the whole list. I just drag a page of this list from the database and show that to the user. And then on the bottom of the web page, let's say I have numbers of pages 1, 2, 3, 4, and so on until the end of the last page. So how would you recommend calculating the number of pages, so to say? Is there an API method in the JPA API that can return me the number of pages? Or I should do a count query, a query that will return the count of the results, and then calculate the number of pages based on that. Or maybe there's even a third or better solution.
No, it's the second approach. So you need a count query that counts all records that are matching your where clause. And then you need to perform a second query, which just returns the page that you want to get. But the important part here is that you really implement a second query that just counts the records that are matching the criteria, which means you don't need to select all the columns. The count is all you need in that query. You don't need to order your query. You just need the where and the group by clause and a very limited select clause so that the database can execute this query as efficient as possible and that you don't need to transfer all of the data from the database to your backend application.
Okay, so you'd recommend putting, for example, just the primary key in the select clause?
It of course depends on the query you want to perform, but in general, yes, counting the primary key is in general the best approach. You just have to check if it really, but if you are creating this same SQL statement with your count query regarding the join clauses and the execution in the database, when you just select the primary key compared to all the other columns that you selected before. But yeah, in general, just the primary key is the easiest and best approach. That's normally also the thing that the databases are optimized for.
Okay.
So if you're not sure about which approach to use and you have a database administrator in your team, then the best approach is, as usual, just talk with your database administrator, and he normally knows what's the best approach for that specific query.
Okay.
Yeah, so I actually love pagination, and I always end up having a couple of issues with that as well. One case is sometimes I have, and maybe let me see if I can tell you about it. Let's see if I can explain it so people can understand it. Is sometimes there are cases where the count doesn't really match the number of results that you get on the select query, and that usually happens when you do joins on other entities when you want to retrieve additional data. Are you familiar with that problem?
Yeah, that is one of the cases I was thinking of when we talked about selecting only the primary key. And I said you need to make sure that you really create the same query as you used to select your paginated result. Normally, either something is missing in the join clause or in the group by clause when you are running into the issue that the count doesn't match the query results. So you need to make sure that you use the same join clauses as you do for your normal query, and that you also apply the same grouping and the same where clause to your count query.
Mm-hmm. And then you have the other situation, which is when you do that, your count might return like a higher number because the count will just count the number of records results. So let's just say you have a parent entity and that one has 2 childs, and I'm doing a left join with the child, so the count will be 2, but I'm only listing the parent entities, and then you get like a count of 2, but you only get 1 result on the page.
Yeah.
Are you also familiar with that? So what's your feelings about it, and what do you recommend?
Yeah, I also had these issues in the past. Yeah, that's always difficult to answer because in these cases your query result doesn't match the data structure that you represent in your UI. So in the case that you described, it's probably the best case to use a distinct on the ID of the parent entity. So use do a select, count, distinct, and then the parent entity ID so that you just get the so they first get a set of unique primary keys of the parent entity, and then the database counts the number of these IDs. But that's something that you have to analyze for each query that you want to implement.
Yeah, thank you. So we do actually have our first question from the audience.
Yay.
It's actually coming
We're
live.
halfway through, and our audience is not shy anymore.
Yeah, so this is actually coming from the YouTube channel from from Christopher Toner. So his question is, what are some considerations with using dynamic mappings instead of static mappings?
Yeah, but to be honest, I don't really like the dynamic mappings because I tried it myself in a few projects, and I regularly run into some issues. So in general, Hibernate and JPA as well uses a pretty static mapping with a set of Java classes that are mapped with roots against a database table. And as soon as you don't have the your domain model consisting of Java classes, or as soon as your database isn't static, in my experience, Hibernate isn't the best choice. If you want to work with a dynamic data model, then you probably should have a look at the NoSQL database, for example, and the different driver implementations that are available there. But that's not something that, at least in my experience, Hibernate is really good at.
Okay, thank you. Okay, so Ivan, let's move on.
Okay. One final question about JPQL, if you allow me. So you mentioned about a different approach of running update and delete statements, not by doing a merge or delete a method call on the API, but rather with executing JPQL query. So when would you prefer running a JPQL query or JPQL update statement or delete statement instead of doing it with the API call?
Yeah, I would only do that if I have to update or delete a huge number of entities and if it's a performance critical use case. But what you're basically doing there is you tell Hibernate to generate an SQL update or delete statement that updates or deletes a bunch of entities. That is perfectly normal with when you're working with SQL. But Hibernate caches in the entities in the first and the second level cache. And when it executes the JPQL statement, then Hibernate doesn't know which entities get updated or deleted, which means it cannot update the cache. And then you need either make sure that they are not already in the cache, or you need to invalidate the cache and make sure that Hibernate loads them again after it executed the statement. But that doesn't mean that you shouldn't use the JPQL or also criteria update statement or delete statement. Because if you perform an operation on a lot of database records, then the JPQL update is much more efficient than the Hibernate approach. Because if you use the setters and getters of your entity to update the attribute values, then Hibernate first has to load the record from the database, map that to an entity. The entity is stored in your local memory. Then it performs the update on the entity object, creates an update statement for that, and executes the update statement so that the value gets updated in the database. And then it does the same for the next entity. Okay, maybe you can skip the select part and perform one query that returns 300 entities. But then you still have the 300 update statements, one for each entity. And you can optimize your database as long as you want to do. But if you're executing hundreds of statements within one use case, you will always have performance problems. So in these situations, it can make sense to use a JPQL update statement instead and deal with the caching issues, because that's something that you can solve. But you can't solve the issue of executing hundreds of queries without removing these queries.
Yeah, well, still on this topic, let's talk about a little bit about the drawback that you mentioned, that the cache is not updated when you run the update or delete query, either with JPQL or with criteria API. What could be the consequence of this? What can go wrong?
Yeah. So maybe let's talk about the first level cache, because that is the one that is always used, and it's probably a little bit easier to understand. So when you select an entity from the database, then Hibernate executes an SQL select statement, which reads the record and stores the entity in its current persistence context. And when you either traverse an association to this entity, or if you try to select the same entity by ID or the entity manager find method, then Hibernate will check the first level cache first and get it from there instead from the database. So when you now have a few entities cached in your current persistence context in the first level cache, and you perform either a delete or an update statement that affects these entities, then you will not see this change in the entities that you get from your first level cache, because Hibernate doesn't know which entities were affected by the update or delete statement, therefore didn't update the entities in the first level cache, and they still contain the values they had when Hibernate loaded them from the database. And the behavior with the second level cache is basically similar. The main difference there is that the second level cache is not session specific. It's shared by multiple sessions. So you might load an entity to the second level cache with one session, then another session performs the SQL updates or JPQL update statement, which doesn't update the cache, and all following sessions will use the outdated version from the cache until this cache segment gets invalidated.
Okay, so what you say when it comes to first level cache is that if we use the same entity manager instance, if we talk about JPA, or same session instance, if we talk about Hibernate, we will not see the update, and we invalidate the cache by doing what? Doing refresh?
No, you need to evict the entity from the cache. So the entity manager provides a few methods to remove an entity from the first level and the second level cache.
Okay.
And you need to do that.
I see.
Or for the first level cache, you need to detach that. So the general idea here would be, before you perform the update statement, you make sure to flush your current persistence context, then remove all the entities from the first level cache, then perform the SQL update statement, and then you're basically done. After that, you can do whatever you want, because then Hibernate will need to perform an additional query because the entities you want to use is not in the cache, and then the database would return the updated version, which Hibernate stores in the first level cache, and everything's fine.
So in like a really like edge case scenario, we may end up with something like we update or delete an entity with a direct query, and I still have that entity in my first level cache. So I may end up with the original result that I had before, something like, let's just say that since Hibernate doesn't know that was updated or deleted, we'll just try to update or delete it again, or even like persist it again because it's not there anymore and it's on the first level cache, so it will try to persist it. If
No, Hibernate wouldn't try to persist it because it would know that this entity was already persisted. It would just expect that this entity still exists in the database. So if you would get the outdated version of that entity as long as you don't remove it from the first level cache. And if you commit the session, then Hibernate would.
Well, a merge will probably just override the changes made by the statement, right?
So it might happen that you override the your change if you have if Hibernate's dirty check recognizes that it has to perform an update statement for the entity. So then you override your change, or you might well, in best case, Hibernate's dirty check doesn't recognize any change on that entity, and it will just ignore that at the end of the session. But anyways, during your whole session, you are still working with the outdated version of that entity, and this is normally the one of the biggest issues there. But yes, you also might just lose the update. If Hibernate's dirty check recognizes it has to perform an update, then it just overrides the update that you performed before.
But that in that situation, that doesn't only happen when you actually update things with a query, as we mentioned. It may also happen when you have concurrent sessions looking into the same objects, right?
That's normally something that you handle with the concurrency management. So in most cases, use optimistic locking and the transaction isolation on the database to handle these situations. So the database would take care that you don't see the changes of the performed in the parallel transaction. And then Hibernate would try to okay, in optimistic locking, you have an additional column and entity attribute that stores a version number for the entity. This one gets incremented with each update operation on the entity. And when Hibernate then performs another update, it uses the version in the where clause of the update statement and checks if this update statement updated one record as expected or not. And if concurrent transaction updated the record in the database, then this update statement would not affect any record. The database would report that back to Hibernate and throw an optimistic lock exception.
I see. Yeah, so we don't have any more questions from the audience at the moment, so we only have 15 minutes left. So if any people from the audience is there, just send the questions because we only have 15 minutes left. Until then, we'll just move on with some of more advanced questions. Oh, give me a sec. Actually, got just one right now. This is coming from John Mazuski. I'm hoping that I'm pronouncing that right. So he's saying that he would like to show some performance examples to some of his coworkers. Do you know any demos on the web showing lazy loading? How about demos of tables with millions of rows? So basically, he wants some demos about performance, showcase performance on Hibernate or JPA. I guess you have a couple of them in your book as well.
Yeah, I have a few examples about lazy loading in the book, but I don't have any performance showcases that really show how lazy loading affects that on a huge database. And to be honest, I don't know of any showcase that really shows that. But we can have a look at the thing. So let me just check for the example project. So the Hibernate's fetch type definition tell Hibernate that it should only load an association of entities when it's really needed. So you can choose between lazy and eager fetching. Eager loads the associated entities all the time, and lazy only when you use the associated entities. Now I think it's pretty obvious that lazy loading is the better approach for almost all situations, because why should you load something that you don't need? And it's also pretty clear that loading additional records, independent of their number, takes additional time and resources. When you use, well, but it's still one of the most common reasons for performance issues, that people annotate all their associations with fetch type eager, and Hibernate has to load an entity and initialize a bunch of associated entities as well. So instead of just loading one or two entities, it has to load a few dozens of them, which becomes an issue if you have a lot of parallel transactions going on, or if you have a database with huge associations. So that's always the better approach, to use fetch type lazy. But then you need to make sure that you don't run into the n+1 select issue, which is one of the, but it's probably the second most common issue. You either find an application that has some eager loading issues, or where you have some n+1 select issues. So let me, let me run this test case before I explain the thing here. So author entity, which has an association to the books. So basically, we have one or more authors who have written one or more books, a pretty common example. And it's annotated with a many-to-many annotations. Many-to-many by default uses lazy fetching, which is a good thing. And here you can see, if you just execute the query to load an author, Hibernate also just loads the author entity and no associated books. But what, let me check something. Yeah, but what do you do if you need the authors and the associated books, which is probably quite often the case? You need the parent entity with the associated child entities. You could now go into your source code and just, we have an example for that here. No, I unfortunately don't have one. OK, so let's say you select an author entity and then just call the getBooks method and tell Hibernate to fetch the associated books on that way. then Hibernate has to first execute a query to get the authors and then an additional query to initialize the associated books for each of the author entities. And that is then the n+1 select issue. You have one query to select the authors and n additional queries to initialize the books. And you can avoid that with the join fetch statement, as you can see here. So this looks almost the same as the normal join clause in your query. And I just add the fetch to it, and that tells Hibernate to not only fetch the authors from the database, but also the associated books. And you can now see here that Hibernate selected both of them together. So that looks pretty similar to an eager fetching. So we select the authors together with the books. But the main difference here is that we decided to do that in our business logic because we know that we now need the authors and the book entities. And in comparison to that, the eager fetching would always fetch the authors together with the books, whether or not we need the books, which is never a good idea.
Mm-hmm. Yeah, I think that's useful information. I also remember that I wrote like something around performance like a few years ago, so I've sent that to our viewers as well on our YouTube channel. So hopefully that will be enough for our viewers to answer this question. So we don't have much time left. 8 minutes. Ivan, do you want to finish up with the last couple of questions? If you don't have any more from the audience.
Yeah, let me ask one question on again. Let's get back to caching. So the second level cache, it's not turned on by default, but you still can use it. And you give an example of turning on a second level cache with cache for Hibernate. If we do that, do we need to separately configure cache or whichever caching solution we picked? And do we need to bring its libraries in our application, or Hibernate somehow does this for us?
That depends on your overall technology stack. So if you're using an application server and Hibernate as your JPA implementation, then your application server will most likely already provide you with a integrated caching solution and a default configuration for the cache. If you are running Java standalone application, then you need to add the required dependencies, which I think I do in the example project. So there you need to provide the cache jar file, and you need to configure it accordingly in your persistence XML file. And if you don't want to use the default configuration of your caching implementation, then you obviously also have to configure it there. But if you're using a Whitefly application server, for example, there you already have I think it's InfiniSpan as a caching solution pre-configured, and also the required dependencies are available at runtime so that you can use the second level cache when you activate it in your persistence XML file.
Okay, thanks a lot.
Yeah, let me just have like a comment here from our audience from Retius Angelbreg. So he states that, for instance, when we were talking about doing the bulk update delete with a query, if we perform this operation in a separate transaction or on the beginning of the transaction before any entry has been accessed, then then we can avoid that particular issue that we're discussing about the entity is not being completely updated, right?
You can avoid that when you do that at the beginning of your transaction. So if it's the first thing that you do within your Hibernate session, what you shouldn't do is start a new Hibernate session and transaction to do these changes, because then you will not see them in the in your first Hibernate session, because then the database will encapsulate the change, so and hide it from your ongoing transaction, and it will also not update anything in your current Hibernate session. But yes, performing these changes as the first operation within your Hibernate session is one way to avoid the update, the cache update problem.
Okay, and we are pretty much almost out of time. Ivan, do you still have time for one super quick question?
I don't have super quick questions. Besides our standard super quick question, which we use to conclude reviewing a book, which is, Thorben, do you plan a new book or a sequel to this one, second version?
I will most likely publish an updated version of this book in probably 2018. And I'm thinking about writing another book, but then no concrete plans at the moment. So I have a few ideas, but nothing I can really talk about at the moment.
Okay.
Right now, I'm focusing on my online courses and classroom trainings, and not really on a second book. It was an interesting project, and I will do it definitely again. But I think I need a short break from all the writing.
Okay, sure. Yeah, I mean, we were very happy to have you here with us. Thank you so much for joining us for these 2 sessions. And I also remind everyone else that we actually did your book launch here live on VJug, which was like the first time we have done it here on the VJug. So we were happy to be part of it as well. And so thank you so much for your time here and for all your expertise. I'm pretty sure that if anyone else still has any other questions, they might reach you out on Twitter or email or your blog and send their questions over there. And we'll be happy to have you again if you come up with another book. So let us know when you have something available, and we're happy to have you back again on the VJug, on the Book Reading Club with a new book.
Yeah, thanks for having me. It was a pleasure to do these 3 sessions with you and talk about the book in more detail. So yeah, here's shameless plug of the book. You can get it on hibernatetips.com or on Amazon. And yeah, I hope you enjoy it. Yeah,
we did. So guys, if you need some Hibernate stuff, Thorben is a man to reach for, and his book. So now the Book Reading Club is going to go on a few vacations. So we're probably just going to return with a new book on September. So please follow us or keep following us on the Meetup website and our Twitter handle, and we will give you updates there with a new book and new sessions on the Book Reading Club. And we'll definitely plan that for September. In the meanwhile, we're just going to rest and prepare for the next book. Thank you so much, guys, for watching, and thank you, Ivan, for being here with us as well.
Thanks, everyone.
See ya in our next Book Reading Club session. Bye-bye, guys.
Bye-bye.
Bye.